All
right, everybody.
Probably,
good morning.
I don't know, what,
from
60
the
meters
NOAA
off the bottom or 50
Okeanos
meters off the bottom is
Explorer.
good. Yeah.
My name is Chris Kelly. I'm from the University of Hawaii's School of Ocean and Earth Science and Technology. And next to me to my right is...
This is Chris Mott from the Smithsonian's National Museum of Natural History.
And
Is that all right? Yeah.
Nicola Rodriguez from the University of Hawaii at Hilo.
So when the ROV team is a little less busy, we'll get them to introduce themselves.
20 below.
But we are providing you with a live broadcast this morning from the deep sea floor on an unnamed seamount well south of Johnston Atoll. That was only mapped a couple of days ago by our mapping team here headed by Mashkour Malik. So this is really exciting. No one's ever even seen the topography on the seamount, and no one has definitely
80
ever
meters on
dove
Sirius
on
and
this
50
before.
meters on D2.
So this is true exploration.
Yeah, altitude lock on D2,
You're gonna,
94 meters.
You're going to see it as it happens right along with us. And I wanted to tell you also that we are in the Pacific Remote Islands Marine National Monument, Johnston Atoll Unit. So we are in a marvelous monument here in the Pacific that's comprised of a whole bunch of different atolls and islands. Chris, what are some of them?
Some of those atolls and islands include Palmyra and Wake. The other ones.
Okay, so I'll go down to 40 meters above the bottom, go into depth hold, auto depth.
Yeah.
Yeah, it's
I put you on the spot. Sorry. Anyway, this is really fantastic. We are delighted to be able to help the monument management agencies, which include the National Marine Sanctuaries Program, NOAA Fisheries, other NOAA agencies as well. Pacific Islands, let's see, I'm trying to think of all the different types of agencies that are involved in managing this monument. I think the U.S. Fish and Wildlife Service is involved. And we're delighted to help them understand what the deep resources are in their waters.
If we can, please move rotation
all
center
right,
to A-frame.
I promised you a really stupid joke.
Serious.
Every single, we're going to, Kelly gave me the messages that I'm supposed to do, but I'm going to do them a little later. I'm going to give you the really stupid joke first. And I promise that if you sat through our introduction,
Sirius is holding at 50 meters altitude.
So this one
so you can come down to
comes from
40
Dave
30.
20 below,
Casagrande, Day, one of the ROV team.
And then what I find useful is to go ahead and lock in auto head.
Yep.
What did the Pacific Ocean...
Auto depth, that's what I'm shooting.
Yeah.
Did the Pacific Ocean greet the Atlantic Ocean this morning?
I don't know, Chris. Did it?
No, it didn't. It just waved.
Oh,
yeah, I think this is a real candidate for the worst, stupidest pun, and that's what we're actually striving for here. So this might beat the Squid Tentacles one that the Interspace Center, I think it was Rebecca, gave us the other day.
D2
and it, no, we got one groan in the chat room, so I'm delighted.
So
anyway, Chris Ritter, the head of the ROV team, or the acting head right now, is getting some experience as acting lead from Dan Rogers. Chris really didn't want Dave to tell that joke, but of course,
just back up until
Dave in trouble because it was so bad.
And you're not even going to have to turn much.
Annie is absolutely delighted because she was worried that her joke was going to be the worst one of the crews.
This one's easy for you. I'm seeing you at the bottom of the bubble cam.
Yep, see it.
And I've got my camera down at 90
well,
degrees.
Chris, here's one back for you.
Copy that.
How heavy is a big frozen block of euphausid crustaceans?
Euphausid crustaceans. Those things weigh a lot, don't they? So how heavy is it?
A kilogram.
Oh my goodness! Look, there we're getting
Are we
people.
at the bottom yet?
No, we're getting threats to turn off the audio right now. Okay, so that's it. We're done for the day.
Yeah, keep back.
And I guess we should apologize, but I don't know.
I'm not going to apologize.
Okay, we won't.
That was brilliant.
60 good
Oh,
or 60 or 70?
Please
or is that
don't encourage him. Tara
well,
just
you can
said
push
she
it back
really
a little
liked
harder.
that.
A
little harder
Chris
than that?
Moss.
Yeah, that's fine.
Oh my
Well,
goodness.
afraid to
Tara's
go
one
too
of
much.
the people
Yeah,
that
no,
I've
you're
bottom things out there.
interacted with on
I
Twitter
see it there.
before.
Yep,
She's
got it.
lovely.
Oh, okay.
Pretty good. Almost
All of
combined
our scientific resources on the shoreside pool who are helping us with identifications and other knowledge are great and knowledgeable people. So, thank you.
Yeah, thank you. So aside from some of our OER folks
Go ahead,
and the Interspace
Hey,
Center folks that are on our
offline
chat
question.
right now,
When
we
Dan
are
is
also
not no
joined
longer on
by,
watch, can you have
Asako
him come to the bridge? We
Matsumoto
have
from the
questions
Student
for some
Institute of Japan,
SOPs.
John
regarding,
Smith
bailout.
from the University of Hawaii,
Right. You can
Oceanography
just like pass it to him
Department,
at some point.
and School of Ocean and Earth Science
right, no worries. Thanks.
Technology. He actually
All right,
has an
so now I'm
office
gonna
right,
start
right
coming
next
to
to
port.
me.
Okay.
Les Wadling from the University of Hawaii's biology
And you
program.
can turn your,
Megan
roughly
Cromwell
20 to 30 degrees
and
to starboard.
Starboard.
Again, I'm trying to remember, Megan. Oh, I'm sorry, Megan, that I cannot remember what your institution is or where you're from.
And what's the general
Scott
slope here?
France, he's from the University of Louisiana
Looks like
in
it's going
Lafayette.
to be
And
easterly or southeasterly.
Is from
what's our
think we
upside?
want
Stockton.
to try to climb
Another one of
up
these I keep spacing on.
directly
Very,
to the
very
east,
sorry, but I will
to
remember
get on
next
top
time,
of it,
Tara.
and then we're
I know that
head
Chris
more
knows it
south.
very well.
Go
And
ahead
then
and
Tim
line
Shank
up on
from the
Probably
Woodsville
mostly
Oceanographic
Okay. We'll
Institution.
both go to 090 then.
And we typically, when we get to bottom, we're joined by other scientists, benthic marine biologists who are interested in the deep sea fauna. So we'll get some more as time goes on. Thank you all for joining. And we are now at 2,400 and about 15 meters.
Okay, watch lead. We're just getting in formation now, and we'll start down to the bottom soon.
I think with
I
the
suspect that we're going to be seeing the
direction of the current here, let's
seafloor
do-
very shortly, any second, because that's pretty close to our drop depth.
let's do more like a 110.
110.
They
copy
usually
that.
do
So
a little
the
bit
tether's not
of
getting blown right up
You can do that.
upslope here.
tasks, if you will, right around 50 meters or so above the seafloor, making sure everything is ready to go before doing the final descent. And we're in that period right now. You can
All right.
see that we're not really
Okay,
descending.
yeah, that looks
Both
good on
there?
The actual
sonar.
particles
Maybe a
in the
little
water
bit
are pretty
more.
stable.
115 maybe? Or
115 looks good. Yeah,
sound good?
we can do that. Yep. Yeah. That agrees
Okay.
with sonar there.
All right.
All right. Ready
All
to
right.
start coming down?
Coming down.
All right.
Yep,
I'm
let's
going to
go.
start coming down slowly.
Okay.
I just heard the word. We're making our final descent.
And the current's going to tend to blow
Chris
you
and
off
I
the
already
side, so you
made
might
our
have to do
descent
a little
this
bit
morning.
of starboard lateral.
Okay.
You mean there's
Keep in
terrible
mind
jokes?
view.
Yes.
Tara Luke, she is pointing out that Stockton University is a small
tilt your camera
university
down
in
a
New
little,
Jersey, but
further down,
yeah,
see
I will
bottom here.
definitely
You got
try to
bottom
remember
inside
because
there.
I certainly
There you go.
should know it.
Yeah.
Know it.
Yeah.
Alright.
you're gonna
Okay,
have to
we
push
have
to
bottom in
starboard.
sight. You'll see it any second.
Bit of a current today.
Yep. Coming over hard to starboard.
I see a lot of rocky substrate here. It looks like a lot of pillow lavas, but we will find out when we get down a little lower.
Interesting that I see flares with the cameras tilted down so low on the left-hand side of the screen.
Oh, yeah. I think that is.
I'm not sure.
Maybe the temperature probe.
Or the craft jaw.
The glint
On the left-hand side?
Yeah.
Okay.
tends to be the craft, that one.
Yeah.
Well, I'm seeing a lot of rocks so far and some good consolidated
Almost there.
substrate, which is a very good
Yeah.
sign. Because that's what a lot of corals and sponges prefer. I'm not seeing our first
Yep.
animal yet, but I didn't think I saw it
coming
the other
down.
day
Yeah,
this high,
still
and
coming down.
they showed up in abundance once we got closer.
Oh, there's. Oh, wait, no, that's a rock. One of the fun parts of navigating these kinds of terrains is the various illusions the rocks form when you stare at them for long periods of time. Especially if you have a search image. Oh, no, there's a stock.
10
well,
meters
it's
off the bottom.
like a dead something
Yeah.
too on the bottom. Yeah, maybe a dead sponge stock.
All right. Do you want to go ahead
Oh
and
yeah,
dial in your
there's
Z
an
bias?
unbranched
Copy that.
coral, and think I see some sponges. So yeah, it's just a matter of getting down a little bit closer.
So what I would recommend is if you come out of auto
there's a nice coral
depth
to the left there.
Okay.
Yeah,
And
I
then,
see that. That's the one
so
I was
now-
thinking. We got a couple of
now you can put in auto depth. You're just resetting your depth.
Okay. Copy that.
And then you'll see what the thrusters are doing to hold auto depth.
Yeah, our
And then you can
videographer
adjust your
Roland
Z-bias
pointed
to
out a
that
stock
amount.
sponge in the
I
back.
see.
So
Yeah.
So,
so
still
there's
going
stuff.
up, though.
Yeah.
It's still.
Give it a second to stabilize here.
Yeah.
You might need
Oh,
to
that's
push.
a good trick. I hadn't thought about that.
Yeah. You might need to push the starboard lateral while you're doing this stuff.
Copy that.
Make sure you don't go too far
Yeah.
over.
Okay, so you're going to want it somewhere around 25, looks like. Try that and see what happens. Okay, now I'll go out of auto depth.
Okay.
And heading down to the bottom.
Yeah, I can see some things sticking up on these rocks. Yeah, they're just hard to see when you're farther up. Of course, you don't have as much light penetration. But yeah, I can see possibly even some chrysogorgids and some other things here. Maybe even a black coral right in front of us as well. These are just guesses until we get a little bit lower, but
All right, can you bump in my sonar, please? Nav?
kind of fun guessing.
We can go 50 meters. And I'm coming back to 115.
Yeah,
We're at
got
50.
some dead sponges
Next.
here
Pilots
too,
at
and it
30
looks
and
like we
working
do have
gains.
some current
Thank
here.
All right, looking good, Don.
Okay.
You've got 2 minutes.
Look at that, we've got some animals. We definitely have some animals.
Okay.
All right, I'm
It's
going to call
interesting
this
how,
bottom.
I don't know
All
how
right.
common
Yeah.
dead
So you've got how much
sponges are.
Z-bias do you have
Wonder
for
why.
your-
I've got 20.
Could be they just don't
3.5.
decompose,
Oh,
and
I
they
think
could
you're
be
going in the opposite
generations,
direction.
generations, and generations.
If
There's
you're
a
off stick.
purple blob on that
Yeah, so you're pushing up right now.
dead
Oh.
stock.
Yeah,
What
we're
we
going to go
might do
opposite.
is get the.
Yeah.
We'll have to see where we
Oh yeah.
land.
See where we end up.
Yep.
Oh, there's a lot of things here. There's smaller things. We're not seeing any huge fans, but there's a lot of things.
Going hard, going hard.
Oh, it's a nice little assortment
Yeah.
to start with, at the
Yeah,
very least.
yeah, and there's some chrysogorgids and primnoids.
Bridge,
and
Nav.
Go ahead, Nav.
We are on the bottom.
Roger, thanks for letting us know.
So we're actually on the lee side of the slope,
probably-
and so
that's
this is
probably
a
pretty
really
good.
good
Yeah,
start
right there.
because typically the
22
lee
is a good
side
start. Yeah.
side
Okay.
is often
Alright.
a little bit depauperate.
Cool.
Okay. Well, looks
Well,
like.
there it is.
Yeah, there it is. Let me set us down here. We're going to have a watch change now.
Okay.
Okay.
Well, Don, I'm glad that I didn't give you a chance to do introductions. Then, if you're just going to bail on us.
Yeah, we're bailing. That's it. Yeah, I think it was the jokes.
Yeah. Touche.
All right, just let me lock us down here.
Very manganese crusted seafloor here. You can tell by all that texture. That's this bubbly texture that's high enough that it actually is trapping sediment in between it. So it gives it this very sort of dinosaur skin look to it. And I think that's kind of fitting because I suspect that the Seamount is probably Cretaceous in age. Okay, so you'll just bear with us for a moment. We are doing a shift change right off the bat in the front row, and then they'll get squared away and they'll be ready to start imaging some animals.
are here, Dave. I'll get your swing arms out.
Okay. Wow, we got an awful lot of stuff lit up on the intercom here. Let's start some of this distraction off here. Listening to OKEX, talking to EXRV.
Hello, did somebody just join the telecom? We're just waiting. Oh, hi, Les. Yeah, if you got any comments, we're just waiting for the pilots to complete doing their shift change before proceeding on. I am not mistaken, the pilot this morning right now is Dave Wright. Am I correct, Dave?
You are correct, Chris.
Even though we know it's a totally solo effort on your part to do everything.
All right, swing arms are all out. Dave?
Okay, as I was saying, yes, even though I know it's a totally solo effort on your part to do everything here in the control room, there are some other people sitting around you that I guess we should name.
1000K ground fault. Pretty nice.
There are. We're just settling in. My co-pilot, Dan, has been here for the whole watch, and his relief is going to be here shortly. So I'm going to hold off on announcements just a little bit longer.
Okay.
And then we'll, but I am at your service at this moment. Do you see anything of interest?
Yeah, to the right of where we are looking right now, I'm pretty sure I saw an Antipatherian, and then a little further right of that,
come down and give you a little more tether,
Chris
Dave.
Saw a red blob, as he described it. But
okay,
blob. Yeah, and if you just take a look right, if you don't see it, fine, because there's a gazillion other targets here up ahead of us, as we can see. But this is pretty sure was a black coral, and sometimes they're not in extreme abundance at these habitats, so I thought
nothing has changed.
Get that one.
Okay, do we see it yet?
Not yet. Maybe pan down just a hair.
Down we go. Is it the pale subject?
No, where is it? It was.
Let me swing around a little
Ready
bit
for
here.
moves.
We'll just do a little surveying around here.
Okay, and I don't know where your pink blob was, Chris, either.
But I think it was on that sponge in the far back on the right side.
Okay,
well,
well,
back on the right. We'll ease over that away.
So there's things we can start with. Anyway, so how about right in front of us, there's a very wispy looking thing that's dead center.
Yeah, zoom please, video.
It's going to be a chrysogorgid, I believe.
I need to get much closer to put some light on it. If you need a better look here.
Yeah, we might. And also, Les, I think, is in the ECC, so he can actually see things in almost real time, like a 2-second delay.
Let's come out a little video.
It's an Exploration Command Center.
Thank you.
That's Les Watling from University of Hawaii, who specializes in chrysogorgids and bamboos and a whole lot of other stuff.
Yeah, Chris, the view from here is pretty good.
Yeah, I'm delighted to hear you got that straightened out.
Lasers, please, co-pilot.
One of the little quirks of the video wall, I'm afraid. But it's a marvelous facility. Les is actually sitting in front of a 12-monitor wall participating in the dive right now at the Hawaii Institute of Geophysics video wall room at the University of Hawaii.
We can zoom video.
Okay, and here we go. We're going to look at our first animal now.
Animals, apparently.
Animals, yep. Les, can you walk us through what we're looking at here with the coral, at least?
Coming left a little.
Yeah, because this looks like Chrysogorgia, that one of the gold corals, they're so-called, have very delicate skeletons, and this particular one is an odd one in that it has dropped a lot of the branches from the lower part of the colony. So, there's a starfish. There are brittle stars. It looks like it's about to drop off. These brittle stars usually don't live on the corals. They're not obligates, but they do get up there sometimes. But if you look at the main axis of the colony, you can see that there are a lot of zigs and zags in it. And those are places where the branches had originated, and now they're pretty well all gone. And there are only branches on the upper part of the colony. And it looks like both of these colonies are pretty much the same, but it's be difficult at this level to tell for sure who it is, although I'm looking at the branching pattern and of the branches that are left, and there are quite moderately large distances between the branches as they originate off the colony. And just below that crab that's sitting up in the colony there now, you can see that there's a branch pointing almost straight up, and then there's 1, 2, and then a third one that's parallel to the first one that we looked at. And that's one of the characters that we can use to help us tell what group of species this belongs to. I'll let Chris talk more about the crab that's in the colony.
Yes.
Sure. So thank you very much, Les. Looks like we've got a little squat lobster. It could be a chirostylid in the genus Europtychus, but maybe not. I don't know these very well, but they got a good image of them. And we're getting a really close look now, and Mary Wickstein helps us out a lot with our arthropod identifications. This looks like he's a guy that we've seen before on these chrysogorgids, a fairly common one. And I'm going to take a quick look at the Okeanos Explorers Online.
While we're zoomed in here, Chris, I noticed a couple of the polyps there are really, really swollen. They look like candy cane almost. And I'm wondering if that is just simply packed with eggs or larvae, or if there's a parasitized polyp. They're on the the left side of the crab. There's 2 of those polyps.
Yeah, I see those, Scott. Thanks for pointing them out.
Yeah, I noticed that there's another one on the other side as well. The low frequency suggests that they're probably parasitized in some way, but I have no idea who that parasite might be.
Okay. Well, thanks very much. We're good for Science Pilot whenever video's ready.
Oh, it's wide, please, Bob.
All right, so let's figure out who our next victim is going to be.
Okay, I'll tilt up.
Very, very distinct teeth.
Pilot and co-pilot, are you guys happy with your sonars?
I wonder if that'll help Mary's identification of that crab.
Okay.
Excuse me, Pilot. The black coral on the right of the screen is what I was talking about. Sometimes
halfway up on.
halfway up, yeah.
Okay.
So these sometimes don't occur very often. So when we kind of like to check it out. There's other primnoids and other things, but
video. Let's zoom from here before I move, and
we'll get this.
See if that's sufficient for an ID.
Yeah, I saw this coming down, Scott, and we're getting a little better look at them right now. Yeah, so Scott France suggested piranopathies, so that's great. There's a possible, of course.
And if you'd like, I'll get much closer, if you like.
I think we're okay right now on this.
Co-pilot,
we have a
would
lot
you
of
like
targets
to
here.
start a move to get closer to...
So I found the one
video?
I was looking for. Chris, did you see your purple
Yeah,
blob?
I think we could do
No, I'm not sure. I
20
think I might have
meters
just
at
seen
my heading.
that
1, 2,
sponge living
0,
on another sponge.
115.
Okay.
Wide, please, video. Okay, we have lots of stuff.
Yeah, we do. So then,
It's kind of unusual, though. Look at these tree-shaped sponges seem to be substrate for these polyopogon sponges.
Okay.
So there's this one on the right, but there's another one just like it over on the left.
yeah,
15 meters,
with the polyopogon
115
hanging
coming
down
up.
below it, which is pretty good. But we could also get one of these white primnoid corals. That's this fan-shaped one in front of you, left center right now.
I got it.
A lot of these dead, what I think are Farreid sponges, these upright brown sponges.
I'm just going to float here. I've got no place to set down there.
Okay.
So
And it is a primnoid, possibly in the genus
Ship move, range 15 meters, bearing 115 degrees,
Norella,
2
but
knots.
we're not absolutely certain. But I think that's as good a guess as any.
Okay, wide, please.
I would support that guess, Chris.
Thank you, Scott.
T for Z bias. Here's some over here that I might be able to image
Copy,
much
Bridge, thank you.
closer if you like. Bottom center, there's a place to set down if you want a macro view.
I think we're okay with that. I wonder
Okay.
if we could go with the stock sponge in the background.
Headed
And
there.
Dave, we worked together long enough where you know me, and you know one of the first things I like to do is...
Introductions.
Introductions, and then what's the second thing I like to do?
Oh, is it time for a joke?
No, it's not a time for a joke. That already happened.
Oh, you have me at a disadvantage, sir.
Let me give you a little hint. ROV seems a little light this morning.
Oh,
It may be just me.
it's rock and roll time.
But
Noted.
just
Okay.
if you see something that looks girthy and free,
Yes,
that'd be fine
okay.
as we go along here.
Dave did that checklist pretty well, though, Chris.
Yes, he did. But Dave, you did not. You mentioned the number one thing we like to do, but I don't. Did you do it already? I think you did.
No, I delayed it because we were still getting settled in up here and lots of chat going on the intercom. But now we have settled into our roles. So we of the front row are all members of the Global Foundation for Ocean Exploration. And we're an organization that operates this ROV and its systems for NOAA. And my name is Dave Wright. I'm your pilot for the next hour or two. And to my left is...
Fernando Aragon, sitting as navigator.
And to my right...
Dave Casagrande, co-pilot.
And further over to the right...
Sitting in the corner, Bob Nutt.
Bob is the video engineer, and he handles all the camera operations because the pilots just don't have enough arms.
Sometimes the video engineer doesn't have enough arms.
Who's clipping?
And it's Annie White back in the clipping chair doing editing today as well.
I knew I recognized you, Anna. Aren't you the person who had that really bad joke the other day? I think it is. Who's next to me on the right?
This is Chris Ma from the Smithsonian's National Museum of Natural History, ever present on the hunt for starfish diversity.
Right, and I'm Chris Kelly again from the University of Hawaii, and I've got Nicole Rodriguez to my left also from the University of Hawaii, Hilo. So there we go with our intros. So now let's get to some animals. All right, so we saw a Caliphacus sponge below us and also a bamboo whip. So how about if we do the bamboo whip, because I think I already recognize the sponge.
All right. Let's get a toe down so we can see it in great detail.
We image a lot of these bamboo corals in part because we've got a couple of regular participants, Scott France and Les Watling, that specialize in these corals, but also that the Okeanos video is so good that we can actually see the microscopic parts of the sclerites when they close in on them. And that actually can lead to a very reasonable identification from video. Sometimes can be very difficult in deep water.
Clear to zoom video.
All right, Scott.
It's actually a lot better in between us. It's just all pulled off to the side.
You and others go through the video and annotate the video to learn something about the species distribution and the biodiversity, it becomes important to distinguish between different kinds of bamboo whips, how many actual species are we seeing. So here, as you just said, we look at the sclerites, and you can see the white reflections, these little lines that kind of look like little dashes that are in the body of the polyp, and then you can see the tentacles. There's also even smaller white lines in those tentacles, so those are another kind of sclerite. Those sclerites are calcium carbonate, and it is the shape, size, distribution, and density of those sclerites that's used in the taxonomy of bamboo corals. And what we can see here there seem to only be these short needles or rods, we probably call them rods, and I don't see prominent needles. I'm going to guess this is a B, maybe even a J clade. Let's see what Les has to say. He's on the phone.
Okay, co-pilot, the ship
so Les, you already did
Scott,
B1. Sorry, go ahead.
I agree. I think B clade is probably the most likely. There's a polyp there in the middle. If the resolution on your monitor is high enough, you can see a lot of very small white dots in it in the lower part of the polyp. And that looks like a good imaging of the scales. And the B clade in particular has a lot of scales in the lower part of the polyp. Scales are sclerites, or these little carbonate pieces that are flat and almost as wide as long, maybe not quite as wide as long, but the light doesn't reflect off them very well because they're not very thick, whereas the rods, which you can see, even some of the smaller rods up the tentacles, the light, they're more dense, so the light reflects off them more readily. But this is a really nice image because you can actually see the scales in several of the polyps as well. Another characteristic that you can sometimes use for the B clade is that the tissue that's running up along the axis is a bit thicker and denser than what we often see.
Clean up to,
but Scott mentioned J clade. There's these whip,
right now it's
unbranched bamboos are present in I don't know, 7 or 8 of the clades that have been identified using molecular genetic methods. And so it's a growth form that's pretty common, and we've been searching for characters to help us tell
really nice.
exactly, how to, without taking them apart, looking at them like this with a video camera, how to tell which particular group of bamboo corals they belong to.
I want to add one more thing to what Les was saying as we're looking. It's now at the top of the screen, and maybe because I'm delayed, it's off the screen. But there was a polyp on the right side that had a somewhat brownish yellow tongue-like streak in it, and I'm wondering if that may have been a prey item, if possibly that polyp had eaten, for example, a polychaete worm. It's the size, shape, and color of it are not something that I would normally expect to see in a polyp, and I don't see it in any of the other ones. It's the one that has its tentacles closed there. That's kind of interesting.
Okay, well, thank you very much.
Spotting. I think that's exactly what that is.
All right, well, pilot, I think we're good for this.
Wide video.
All right, we are going to proceed along, and there's the nice stock sponge, the Caulophacus, which we already noted in our annotation software called Seascribe from Ocean Network Canada.
I believe I see a candidate rock.
Alrighty.
It's maybe large, but bigger is better if we can get it. Lasers, are they on? Where are they? Yes, there they are. Oh, that's a very big rock. But here's an angular one. looking a little detached. I'm just gonna dig around here, see what I can.
Well, Dave, there's a couple of these girthy ones. There's even one closer to you as well.
I'm looking at the one right under the lasers right now.
That one, I was thinking of the one over to the left, lower left there. You see these two that are right here and now left.
Yeah, just left there.
That one, it's a little small, I guess.
Well, here's what I'll do. I'll just get in position and stir things up a little bit and see.
Yeah, if you can get one of those bigger ones, that would be great. But
I can give it a try. I have put some big stuff in the box in the past. And maybe playing. You guys have got a rock mass guesstimation pool going, I believe.
Yeah, and guess who's winning that, Dave?
I'm reluctant to speculate.
Yeah, I know you are, because you know I'm really big on self-promotion. But right now, I have guessed the weight of the rocks. I've beat the others at the weight. This is Nicola and Matt Dornbeck. I am now 5 rocks, I guessed, the closest. Matt and Nicola are both 3. So, yeah, I'm kind of in the lead here. Feeling pretty good about it, too. Yeah. It's a little game we play when we're in the lab just to make the lab work go a little make it a little more fun. Oh, that's pretty good.
Video, this might be a good time to zoom on Sirius and watch him sample.
I think that's a good one, Dave.
Yeah,
if you can.
I think I can get around it.
That's a nice one.
Oh.
Okay.
I'm always surprised by these. They always look larger when we bring them up.
Yeah. Well, that one yesterday, boy. I made the mistake of grabbing it first, and then I was going to lose face if I put it down again, so I had to carry it up the steps.
Video zoom, please. And co-pilot, you could bring the starboard wing in if you would.
Looks like the trace of some little denizen of the deep.
Starboard wing.
Perhaps a mollusk or something.
Actually, I think I scratched it in my attempt to flip it over.
I think that'll suffice. Good.
Okay.
Got
wide, please, video.
For kind of angular types of rocks that hopefully came from pillow formations or pillow lava. This has got some nice angles on it. Reason we collect rocks is because, as I told you earlier, this seamount was only mapped a couple of nights ago, and we have no clue what the origin of the seamount is or when it formed or any of that. And the only way we have a chance of figuring that out is by grabbing a rock and letting the geologists actually do some geochemistry on it. And that rock is in the bin. So thank you very much, pilot. We've got our first collection.
You're welcome.
Okay, I'm going to bring that wing back out.
Roger that.
That's right. They'll look at the geochemistry of that rock as well as some of the morphological characters, the size of the grains inside of it, and so forth. And those will give geologists insight into how this seamount formed.
Yeah, I dropped off there as I was grabbing some data in my notebook.
Yeah, no worries.
From it, yeah, so I lost my thought.
Okay.
But yeah, and what happens to these rocks? Well, we bring them aboard, we put them in the lab, we get all of the collection
and can you come back
data
on
for them all
Sirius
squared away.
HD?
Nicola was just next to me, who just hit what we call the SES snapshot, which collects immediately a bunch of data when the rock or biological specimen is put in the box that includes ID number, timestamp, dates, tentative field ID, latitude, longitude, depth, salinity, temperature, oxygen. So all of this information is printed on the labels. We use special museum paper to actually print our labels. And Matt Dornbach is doing a lot of this. He enters it into the database. He prints off the labels. He'll be ready to go to help when the specimens come up.
I'm lined
and
up
we
on
all
9-0,
join him in the lab. We look for commensals on the rocks. We wash them off. We photograph them very carefully. And then we set them out to dry for a couple days before bagging them up and tucking them to bed. Okay, so back to biology after a short deviation to grab a rock.
Things have steepened up a bit, but there is, oh, this is interesting, a lot of knocked over dead sponge.
Yeah, that bodes well for what we're going to find. We're getting a nice little collection up here of animals, as you can see right on that ledge.
And feeling quite a current.
Would you like another
Can
move,
you describe
co-pilot?
it to me, Dave?
Yeah, I'm going to, we see particles going from right to left right now, and I'm facing southeast. I'm going to attempt to align myself to this current and give you a direction from which it's coming.
Here, I'm going to look at the display in front of me. I have to switch the computer so I can see the orientation of the vehicle. There we go. Okay. So you said it's coming from left or right to left, is that right?
It was previously. I'm facing due south right now, and I'm going backwards. I think it's just a little bit west of south is where it's coming from.
Okay, thank you.
But, you know, in general terms, south, definitely out of the south.
Okay, that's pretty interesting because yesterday morning we noted that the current began at our previous dive site. It's a bit north of where we're diving today. We noted it started out from the south, and during the course of the day it shifted and started coming out of the north.
Yes.
So, okay, so let's go ahead and see if we can go ahead and move up slope and find some more creatures.
Upslope is east?
Yeah, they're slightly on the west of the crest of this. That was sort of the dive plan.
So, locally, let me raise my gaze here.
Is that a white? Is that sediment or a?
Well,
yeah,
we're going to go find out.
Yeah,
well,
no, it's sediment. Never mind. Thank you. Sorry.
In the distance, however.
Okay, you might be talking about the sponge
now,
there.
We can probably get moving.
All right. Are you comfortable with 20 or you want 15?
Oh, we want more than
Probably
that.
30.
We have ways to go
feathers
here.
pushed out.
You could even go more than that. I'd be okay with that.
30 and then 090.
Sure. 090 works.
Copy. Coming up.
So my perception of local up is 125, but that's
Go
just
ahead, Nav.
right off, right in front of my
Well,
nose.
that does agree with the high pack, but they want us to get up on top of it.
Understood. I'm just
That's range
I
of
think
30
that sponge
meters,
up there is
bearing
going to be
090,
kind of a fun
speed
one.
vessel
I have a
2.
guess on what it is, and if it's what I think it is, they're pretty wild-looking sponges.
let's
when you
zoom
get
from
close
here
to 'em.
video, and I'll move in as tether allows. That's good from here.
No,
RV nav
it's
bridge,
on
we
a
have
dead
30
sponge.
meters,
Another one of these
090,
polyopogon growing on
I
a
think
dead.
we're looking at it at an looking on angle sort of thing.
So what is going up with this? They don't like the hard rock. They want to settle on the bones of their predecessors.
Well, my guess would be that when they're sitting, when we see them normally, they're standing upright to adjust to a current, right? So maybe they settle on these and adjust to filter the currents in a way that is to their liking.
We can see some waving around in the current here on that nearer coral.
And it looks like we have a little feather star sitting on top of it.
So you got some brittle stars and feather stars in view here. I think that's good, pilot.
Nice wide, please. Video.
We got another chrysogorgid coral. We're still a little ways up and a little ways off, so that's why it was a little dark, the image there.
Quite clearly see the particles flying by here.
Yeah. And we see these rounded mounds of substrate here are most likely manganese-covered lava flows from a long, long time ago when the seamount formed.
There seem to be a lot of particles, a lot of food here.
Yeah.
Sweeping by.
So we're just waiting for the ship to move before we can continue on.
I'll do a little bit of a wander here.
Those of you who are new to the Okeanos dives, you may be wondering, oh, why can't we just go? Well, it's because we have basically over a mile of cable above us, and before we even look at that mile of cable, we have a tether to another vehicle called the Sirius vehicle that's above the ROV, and it shows the ROV exploring the seafloor if you go to feed 2. But you have 3 vehicles involved when you do any move. You have the ship, you have the Sirius, and you have the D2 ROV, and they all got to be lined up properly in order for us to proceed. So that's what happens. We will take periodic pauses to line up vehicles and then make our moves. Lots of chrysogorgids here, and some primnoids too.
Doesn't look like there's nearly as many of them as those dead sponges.
Yeah, a lot of. This used to be quite a sponge place, I imagine, at some point. If we're waiting, pilot, we could get a zoom on that primnoid coral that's right in front of it, the fan-shaped one.
Yeah. To the right or left?
To the left of center.
Okay, here we go.
And then maybe even another one of these chrysogorgids. I think you see a bottle brush chrysogorgid that it's different than the one we imaged when we landed.
Okay, video, you can zoom. I'm going to go to the right simply because the current will aid that. That's
Les pointed out, nice death assemblage of sponges. Okay, so Les or Scott, would you like to comment on this particular chrysogorgid?
Yeah, Chris, trying to get a view of the branching pattern on this one. Looks a little bit different from what we've been seeing, with the branches a bit more close together. Also, there are, you'll notice at the bases of a lot of the polyps, there are white dots. And this one's making me wonder whether this isn't one of the groups that we affectionately refer to as saddlebags. As the polyp matures and develops, the ovary develops, and the eggs are stored before they're released. They're stored in these pouches that develop below the polyp and hang kind of down and around the branch.
More so if you got it.
There's a couple of spots where you can see that there's like a pair, one on either side of the branch, and that's why when we first discovered this in the Atlantic, we called these saddlebags because they kind of look like saddlebags that you might have on a horse or maybe even on a bicycle with material in it. And this is a fairly distinctive morphology for mature chrysogorgia polyps. So, and we've seen it in several places now.
Okay, co-pilot, the ship should be coming to a stop.
Thank you, Les. And we're probably good for science now.
And I'm going to swing to
Thank
the
you, Bridge.
left and pick up the
Primnoid, I'll bet.
Primnoid, yeah.
So go on forward. There's one of these dead sponges that's most likely, there's a little bit of live material on it in the back, but it's most likely in the family Furiidae. And we're continuing to swing, and you're going to see a different, completely different type of octocoral somewhere.
It's
the little sponges on the seafloor there. There he is. And we're getting sort of a side view of this. It's a fan-shaped coral. We're kind of looking along the axis here, and kind of gives us a nice view to see what's growing on it, Chris.
Oh, zoanthids. Or sea anemones.
I think these might be sea anemones because they aren't connected to one another.
So this is what we sort of saw from a distance before that both Scott and I thought would be Narella. I think we're good for science whenever video's ready. And it's nice to then get our close-up of that species because it gives us more confidence as we go across the seafloor and see similar colony morphologies that we're IDing them as best we can correctly. Alrighty, well, why don't we go ahead and start proceeding up slope and get up toward the crest, where I'll bet we're going to find a lot more stuff even. The crest is not very far ahead, by the way. It's fairly close. We're just slightly on the west side, so we're going to be there momentarily. So pilot, that sponge to the right is different. Hey, we could even do a snap zoom the live one finally. We're getting, this could be the same species live, but I suspect it's something different.
Let's zoom from here, video.
Alrighty.
Annie.
And it's
Just
not
here to
different.
surprise you.
This is in the family Furiidae, so that shows you what the live one looks like. And look at that.
Lasers
it's all
off.
messed up by some kind of echinoderms, isn't it, Chris?
They're not messed up. They're just hanging out there. So these are feather stars. They're filter-feeding echinoderms. They extend their arms up into the water, and they can catch organic particles as the water brings food to them. The one that's on the bottom there, if we can zoom in on the arms, those little white dots.
Come on in some more.
Thank you, pilot. These are really interesting because these have parasites on them. These are little snails in the family Eulimidae, and essentially what they do is they have this proboscis, and they just kind of stick their proboscis into the crinoid's arm, kind of like the way you stick a straw into a juice box, and they just suck the juice particles out of, or the body fluids out of the crinoid.
Are they like deep sea ticks?
Yeah. You know, I've never heard it expressed like that, but that could very well be an interesting analog for them. Eulimid snails are actually found in all of the classes of echinoderms that I know of. They're found in crinoids. They're found on sea cucumbers. We saw one on a sea cucumber yesterday. We see them frequently on sea stars. Okay, so it really depends. But this seems to have an unfortunately quite a heavy infestation. There's 1, 2, 3, 4. I think I counted another 2 or 3 on the right as well. So some 6, 2, 3, 4. Yeah, there's 5 of them right there. It looks like 2 of them on one pinule. So yeah, it's a fairly heavily infested one. That arm on the underside might be from yet another crinoid. Also, this affords us a nice quick shot of the underside of the crinoid. So that center circle is the mouth where all the arms converge, and then you can see that kind of triangular structure that's opening off, kind of offset to it. That, I believe, is what's called the anal vent, and that's where all of the poop goes when it's done. It just sort of carries all of the stuff away from the mouth, so it doesn't, how should we say, get confused during input. Anyway, we're done. Thank you.
Let's come out a little bit there, Annie, and get the
Chris Kelly, I really
picture.
like that comparison of the Eulimit snails to the ticks. I think that's great. Little parasites that are sucking fluids from its host.
That's a poster
Yeah, and
shot.
another point, just as a follow-up, is you're seeing a couple different levels of associations here. So the crinoids are probably benign associates for the sponge. In other words, they're just up on the sponge, getting up in the current flow a little bit more, and they're not really hurting the sponge. That's sort of a commensal type of relationship, I guess you could say. But then those snails are definitely having, that's a parasitic relationship with the crinoids.
Yeah, so that sponge is practically a whole ecosystem unto itself.
Yeah. All right, let's see if we can find some other cool things. So far, the community is dominated by a few bamboo whips, a lot of chrysogorgids, a lot of these Narella primnoid sponges, and not that many more different things so far. Couple of polyopogon sponges that are settled out on the dead sponges, and there's another one in the distance. What is wrong with the rocks? I don't get it. These things are normally attached to rocks.
Well, clearly you scared all of them off after we collected that first one.
I guess so.
We could probably get another move in.
You know, you always see sponges growing on other sponges, but you also see them on the bottom. It's like they don't.
Sure.
It doesn't really matter. And so here's a perfect example. I wonder, Pilot, if we could get a look at the one on the left, because this shows everybody what we're talking about here.
Co-pilot.
I think we could do 30.
A little bit more zoom, just a partial here as I want to pirouette. Let's hold that. Just
so there's the dead sponge, and the stalk is the dead sponge.
So that's going
it's
to be
not part of the living sponge. Now, as he spins around here, which is giving us a great view, the living sponge is actually kind of clasping onto the dead sponge about halfway up its stalk.
Anywhere in that range would be fine.
And this sponge you often find on the rocks quite a bit. They'd have no trouble attaching to rocks. And so I'm not getting it. I'm not understanding at all why a lot of these are on sponges. And see the one in the back, it's on a sponge, a dead sponge again.
Could I speculate?
Sure, please do, Pilot.
Well, right now it's a high current environment, and I wonder, if the larvae get caught in the dead sponge, rather than bouncing along the rocks. How do they attach when they first in their infancy, I guess?
Well,
that's
a good question. I don't know, but I assume that the adults attach by grappling the bottom with modified spicules, which are hard parts with hooks on the ends of them that are called basalia. And usually they don't have any trouble grappling the seafloor, but the larvae, we don't know. Maybe that could be it. That's a very interesting idea or hypothesis, Dave.
Is that what?
That could be it, actually. I really don't know, because it's rare that we see really small ones and can discern their attachments.
Video wide, please.
So these sponges. Yeah, so he basically suggested that the larval sponges actually get caught up on these dead sponges because there's so many of them, and then they just start settling out there where they stick. And he said it could be also that the larval ones have more trouble. Sorry, I'm going to interrupt for a moment. To the left center, Dave, we've got a pink coral. So he was suggesting that the larvae may have trouble in a high current environment with however they attach to the substrate, and it's easier for them to stick on a sponge. It's interesting. Okay, we're going to zoom in. What's that?
I was just saying that is not a bad idea, that basically it's current flow related. I would say that that's the two sponges that we were looking at there have certainly been growing for some length of time given their size, and you would think it might be kind of tenuous to be growing on these other sponges given how many we see tipped over, and yet clearly it's been doing pretty well for a long period of time.
Yeah, I agree. And at some point, they're going to get big enough where they're going to be too much weight for that dead sponge, and they may knock it over, and then that's it.